This week, we are moving into second grade. There are four main clusters that we're going to talk about. So we're going to do two this week and two next week. This week, we're focusing on operations and algebraic thinking, and then expanding our knowledge on number and operations in base 10. So let's start with operations and algebraic thinking here. It doesn't look like a lot, but it does entail quite a bit here within the clusters. So we need to represent and solve problems involving adding and subtracting, add and subtract within the number 20, and work with equal groups of objects to gain foundations for multiplication. Some common manipulatives that are used are objects for counting, 10 frames, double 10 frames, hundreds, chart cards, number line to 20, an open number line, part, whole chart, place value chart, various dice, and various spinners. Students should continue to have access to materials including linking cubes, place value materials, 10 frames, and counters to model their problems. Some students may be ready to use pictures to represent their thoughts. Encourage students to use materials or draw pictures in order to determine a strategy for solving a problem. As the situations become more sophisticated, you should see that their models or drawings also become more sophisticated. So in first grade, students worked on solving problems using one step. Now in second grade, we're going to involve solving two-step problems, such as Tina had 12 pencils. She bought a package with 8 pencils. She gave 4 pencils to her little sister. How many pencils does Tina have? So let's describe this using an open number line. So an open number line doesn't have any hash marks on them. You create them as they need, and it's more for a directional sense. So we're going to start at 0 at the bottom of our arrow there, and Tina had 12 pencils. So I'm going to jump to 12 because that's how much she currently has. Well, then she bought a package of 8 pencils. So if we add 8 more to that, we now have 20 pencils altogether. Then she decided to give 4 pencils to her little sister. So if she had 20 and she's giving away 4, that means we need to subtract 4. So we need to take our arrow and go backwards 4 units to 16. So we started at 12, we jumped 8 to get to 20, and jumped backwards 4 to get to 16. So the two steps that we did was addition and subtraction. So let's use this same problem, except let's show using linking cubes instead of a number line. So we have 12 pencils, so I used one linking cube per pencil. So if we count them, I've got 10 across the top and 2 across the bottom. She bought 8 more, so I'm adding 8 more linking cubes. So now we have 20 cubes all together. If she gave 4 to her little sister, I'm going to take 4 linking cubes and take them away, leaving us with 16 linking cubes left. Anthony had 25 cents. He lent 10 cents to Mark. Then Louise gave him the 5 cents she had borrowed earlier. How much money does Anthony have? So let's use a number line. So we had $0 and now we have 25 cents. So we jumped 25 cents. But if he lent 10 cents to Mark, that means we need to subtract 10 from what we had because we gave some away. Now we're at 15 cents. Then Louise gave him 5 cents. So we get to jump 5 cents more. We are now at 20 cents. So we started at 25, we jump back 10 to get to 15, then jump forward 5 to get to 20. So 25 minus 10 plus 5 equals 20. Louis wants to give $15 to help kids who need supplies. He also wants to buy a pair of shoes for $39. How much money will he have to save for both? Let's show using a part whole chart. So here's our part whole chart. Remember, the two bottom pieces from previous grades are the individual, the whole is how much total we have. So part of our part is $15. The other part is $39, And altogether, we want $54. So 15 plus 39 is 54. So Louis needs to save $54 for both events. Note, there are many different ways we can decompose the addition. So some thinking patterns, some addition patterns, such as breaking apart the tens digit from the ones digit, replacing 15 with 10 plus 5, and 39 with 30 plus 9. We're going to regroup them. We know that we can use the associative property to rearrange them. So putting the tens together and the ones digits together, giving us 10 plus 30, which is 40. And then 5 plus 9 we know is 14 just out of rote memorization, but we decomposed 5 plus 9 to get a group of 10. So I regrouped 9 into 5 plus 4, giving me a group of 10 plus 4 more. So being able to teach strategies so that students can do a little bit more mental math, breaking and decomposing numbers. So we know that we need to save $54. If Louis gets $5 a week for his allowance, he plans to save his allowance every week. How many weeks does it take him to reach this goal? So let's start with this by using a number line. And there's other ways to show this as well, but I'm going to use a number line. So I've set up a number line such that we're jumping by fives because we get $5 a week. So when I start at 0 and I jump to $5, after 1 week, I now have $5. Jumping another one, after 2 weeks, I now have $10. And I continue this until I reach enough money such that we get to 54. Now note that by counting by fives, note that counting by fives, 54 is not a multiple of 5. So we would need to save to the 55th dollar in order to have enough to reach $54. We can count how many loops it took us. Each loop represents a week. It will take Louis 11 weeks to save enough money for both his items. Louis remembers his sister's birthday is next month. He sets a goal of saving $16 for her gift. How many weeks does he have to save his allowance to reach this goal? It will take Louis 4 weeks to save for his sister's birthday. Using this exact same number chart here, 5, 10, 15, 20. We'll need to go to the 20th dollar in order to make enough for 16. So if we count how many loops that was 4 loops, each loop representing 1 week. How many weeks does he have to save his allowance for all 3 of his goals? All 3 of his goals being the kids who need supplies, the pair of shoes, and his sister's birthday. We could use a part-whole chart to determine how much money we need to save. So the first part we knew for the 2 first items was $54, plus we need the $16 to reach his sister's birthday present. So altogether we need to save $70. So again, we can break that down similarly to the previous problem. 54 plus 17, 50 plus 4, and 10 plus 6. I'm sorry, there's a typo. This should be 16. There we go. That makes more sense. Okay, so 54 plus 16 gives us 50 plus 4, so breaking apart the tens and the ones, plus 16 breaking to the tens and the ones, 10 plus 6. Combine the tens together, which gives us 60. Combine the ones together, building us already to 10, so 70. Note, though, that we'll need to continue our loops until we reach 70. So by doing that, then, we can count our loops. It took 14 loops to reach Louis' final goal. So it'll take 14 weeks for Louis to reach his goal of $70. A pencil costs 59 cents and a sticker costs 20 cents less. How much do a pencil and a sticker cost together? Let's tackle this with a bar diagram. So let's let 1 full bar equal the total cost of the pencil, so 59 cents. I know that the sticker costs 20 cents less than that being the pencil. So the sticker is 20 cents less than whatever the pencil costs. So I'm going to take away 20 cents from the pencil in order to get the sticker cost. So we need to know what that leftover piece is in order to find out how much a sticker is. The thing I ask myself is, how many plus 20 gives me 59? We know that that is 39 by counting forward, I guess we could say. So a sticker costs us 39 cents. We want to know how much it costs altogether. So if I have a pencil for 59 cents and a sticker costs 39 cents, how much is it altogether? So 59 plus 39 is 98. A pencil and a sticker would cost 98 cents together. Some homework for you. Lucy has 18 apples. She has 9 more than Marcus. How many apples does Marcus have? Use a bar diagram to model your thoughts. Give the final answer in a complete sentence. Problem number 2. Lucy has 24 apples. She has 9 less than Marcus. How many apples does Lucy have? How many apples does Marcus have? Use a bar diagram to model your thoughts. Give the final answers in complete sentences. Create your own problem by filling in the parentheses. Use a bar diagram to model your thoughts about your problem and give the final answer in a complete sentence. Lucy has blank apples. You fill in a number, any number that you want. She has 9 more or less than Marcus, so you choose more or less. How many apples does Lucy or Marcus have? So you can choose which statement you want. The previous problems are located on a printable worksheet in the Parts Unknown Dropbox. Print and use paper pencil to work through the problems. When complete, scan and upload your work back into the appropriate Dropbox. The next set of problems, we will try to build and promote fluency of adding and subtracting instead of simply using algorithms or memorization. Rather, we will work through the problems using properties of numbers and use a number line to help work through them. So let's start with 4 plus 10. So 10 being a milestone number, I can jump using an open number line. 4 plus 10 more gives me 14. Now 4 plus 12. Well, I know that 12 is just 2 more than 10. So if I use my milestone of 10, 4 plus 14, or 4 plus 10 is 14, and then I give 2 more, 14, 15, 16 is 4 plus 12. Notice the result is just 2 more than the previous problem, as described. Let's do 4 plus 22. Or that could be the same as 22 plus 4. I know that 22 is the same as 20 plus 2 plus 4. Then we know that 4 plus 10 plus 2 plus 10 also gives the same result. So why do I go back and rearrange them? Well, going back to that very first problem we did, we had 4 plus 10 gave me 14. The second problem was add 2 more to get to 16. And now we just need 10 more to 26 to get 4 plus 22 to get the same result. Let's switch it up a little and think about 8 plus 20. We can decompose 20 into jumps of 10. So 8 plus 10 is 18, plus 10 more is 28. So 8 plus 20 is 28. Some may look at the commutative property, 20 plus 8. We start at 20, jump 8 more, and we get to 28. So sometimes looking at it the opposite way is also helpful. There are 18 students going to a baseball game. Model with cubes to show if each student will have a partner.